let's look at residuals. Residuals are really cool because what they do is they show us the difference between what we actually saw happen in the response variable, the observed value, and what the equation is predicting the value should be. So the predicted value from the regression line. So the formula to calculate a residual is we take the y value that we observed and we subtract off the y value that is being predicted from the equation. So we're going to do this a couple of times. We're going to use an equation that we're actually already familiar with. We have the equation to model the relationship between the number of hours a student studied for an exam and then the score that they received on the exam. And that is modeled by y hat equals 5.43x plus 76.4. And now what we also have is the data table that was used to create this linear regression equation. So what we're going to do is we're going to find the residual for the student that did not study for the exam. So we're looking at this student here, the student with 0 hours studied. So I'm going to start by writing down the x value is 0, and then the y observed value, this is what they actually got on the exam. So their exam score was a 75. These are my observed values. The student did not study, so their x value is 0. And as a result, they scored a 75 on the exam. Now I'm going to use the equation to determine what the predicted score would have been for this student. So 5.43 times x, and in this case, x is 0, plus 76.4. Multiplication comes first. 5.43 times 0 is 0, plus 76.4. So my y hat, which is my prediction, equals 76.4. And then the residual is the difference between what I observed, which was a 75, and what was predicted, which is a 76.4. And that is negative 1.4, I think. I'm going to double check because it might be a 6. Nope, it's negative 1.4. I was right. So the equation is off by 1.4, not bad. And then because the equation predicted a higher score than what we actually saw, this is an overestimate. The equation is overestimating what this student was able to achieve on the exam. And that's it. That's the residual. So now let's do the same thing again for the students that studied for 1 hour. So it says students because we have this student here that scored a 78, and we have this student here that scored an 85. So we have 2 students that scored or that studied for 1 hour. So x equals 1 for both of these, but now I have 2 different y observed. I have the y observed that was a 78, and then I also have a y observed of an 85. Let me just come up and double check that. Yep. I'm going to use my equation. 5.43, plug in the x value, which is 1, plus 76.4. 5.43 times 1 is 5.43. And then 5.43 plus 76.4 is 81.83. And even though I have to do the residual twice, I only have to do the formula once because I'm plugging in the same x value. Both of these students studied for 1 hour, so they have the same predicted score. So now for the first student, their residual is their score, 78, minus 81.83. And that is minus 81.83, negative 3.83. And again, this equation is overestimating this student's score. The second student, their residual calculation is an 85 minus 81.83. And that is 3.17. And now the equation is underestimating. And it's over and underestimating by almost the same amount. So what that tells me is if I had the graph of this, I would have on x equals 1 on my graph, I would have a dot here and a dot here, and then my equation is going right in between the two dots. And that is exactly what it should be doing. If I have two dots on the same x value, I want my line to be going right in between the two. So that's great. I don't want it to be getting closer to one or the other. It happens because of what all of the other dots are doing. But this tells me that for this x equals 1, it's doing exactly what I want it to be doing. It's going right in between them. It's almost perfectly in the middle. And this is great. And that is how you calculate residuals.